Okay. So Monday we talked about solving polynomials. We didn't really get too far with that. All right. So we talked about, let's see. The first section we did a lot of just the basic graphs of them and the end behavior and the turning points and x-intercepts, right? So then the second lesson, which had all that stuff in it, most of it wasn't as useful because of technology, and we kind of scratched the surface of solving. So let's just talk about that a little tiny bit. So one of the things we said, so we have a third degree right here, third degree. And if we graph it, all right, how many x-intercepts do we think we're going to have? 3, right? We think there's going to be 3. But we're not sure. So let's graph it. But I'm going to let you graph it because I don't want to bounce back and forth. I think what I'm going to do is put it in my phone, though, so I can see it. Okay, so we're looking at it. How many x-intercepts does it have? It does have 3. All right, so look something like this, and like this, and like this. What are those x-intercepts? 1.532. 0.6, you said?
347. 0.347. Oh yeah, never mind. Mine is wrong.
Well, yeah, that's all right.
It's 1.929. And then 0.82. And then minus 1.077.
Okay. So here's a 3 x-intercepts, right, that we got for that. So those are the 3 solutions that we would have. These are our 3 solutions. The only thing is they're not exact solutions. They are estimated solutions because we're never going to get an exact answer unless it's nice, okay, out of Desmos, right? Those are just solutions, right? So if we were to take that graph and let's bounce it up a little bit. So let's say that we raise it up. So right now I have a plus 3 there. What happens if I make it a plus 13? So let's say I take, here, let me give this a name. I'm going to title this. I should have called it f of x in the first place. I'm going to call it f of x. So let's say I take that graph and I add 10 to it. Okay, so I'm going to check that out on my thing here. So I'm going to add 10 to that. How many x-intercepts do we have now? 1. So it looks like that. And that x-intercept is, what do we get there? Oh, I added 10. Sorry. There we go. Yep, 1.49 negative. Okay, again, that's not an exact solution, it's just an estimated solution. Okay? So that means that I have a degree of 3, and when I asked you before, you said, well, it should have 3x intercepts, thus 3 solutions. But here, we raise it up, and now it only has 1 solution. So we chatted a little bit about that last week, or on Monday. So what does that mean about the other 2 solutions? They're imaginary, okay? They're imaginary. So I have 2 imaginary solutions here. So if I want to find those, then I have to come up with some sort of a way to do that, okay? Because again, I can't, there's no other way. I can't use Desmos to come up with that graphically. I have to come up with another way. So that's kind of what we're going to look at tonight is how do I find or how do I go about solving these when I have imaginary solutions? Because pretty much everything that you do in 3-2 is going to have some pretty nice solutions. I could actually bring this down, and I'm not exactly sure how much it would take, but I could have it so it looked like this, right? How many solutions does this have? It still has 3 solutions. How many x-intercepts? 2 x-intercepts. So what's going on with this one that has 2 x-intercepts, but we know it has to have 3 solutions? So what's going on with this? What's going on here? That's a double root, right? Okay. 1, 2, 3. That's a double root. So you have to be careful a little bit because the other thing that we talked about was if you have one can you have just one imaginary solution? Can you have just one? Well, let's think about it for a second then, because this is an important idea. So if we had a quadratic that looked like this, that all of us know how to solve by using the quadratic formula. So if we had a quadratic and we wanted to solve it, and it looked like that graphically, didn't have any x-intercepts, we know that it has to have imaginary solutions. And I start putting my numbers in here. -48, -13, all over 2. Okay, so here's what I have. So I have this -13. All right, 25 minus 48 should give me that -13. No, it's 38. I need 23. Sorry, 23. So I get -23. All right, but here's the deal. I have a plus or minus here. Okay, so that means that we're going to have 2 solutions, 1 plus and 1 minus. So we're going to have 2. So we cannot have 1 imaginary solution. There's got to be 2. All right, so that's why on this one, this cubic here, it has 1 x-intercept. It has a double root. The only possibility we can have, we cannot have 2, or we cannot have 1 imaginary solution. There has to be something going on there. All right? You can't have just 1. All right. So here's what we're going to do. Let's go ahead and solve some of these. All right? So we're really going to get down to the solving these finally. So here's the first one we're going to take a look at. x cubed minus 3x squared minus 3x plus 1 equals 0. So we're actually going to solve this. So our first tat would be to graph it. So go ahead and graph it. Okay, I'm going to let you graph it. Tell me what an x-intercept is. Did you get one yet? Sweet. Mm-hmm. Okay, so again, we have -1 and then 2 estimated solutions, right? Okay, so let's say we want to be a little more exact than that. All right, that's what we're driving for. Is we want to get not rounded estimated solutions. We want to get exact ones. So here's what we're going to do. We're going to take this cubic and we're going to perform some synthetic division on it. So our x-intercept is -1, so that's what I'm going to divide it by. All right. Okay, so synthetic division. Here we go. Hope we kind of remember. We're going to slide down to 1. Okay, then what do we do with this 1? Multiply by -1. Good. That's going to go there. And then what do we get down here in the bottom here? -4. Good. And what are we going to get here? 4. Good. What are we going to get here? 1. Good. And then we're going to get, and so we get, and 0 is a good thing. Because that's what we should get. Right? If this is an x-intercept, okay, that was in that section 3 too. If this is an x-intercept, then we better get a 0 here. If we're not getting a 0 here, something went wrong. All right. So now that we have this, okay, essentially what we just did, right, is we took this polynomial x cubed minus 3x squared minus 3x plus 1, and we divided it by x plus 1. So when we divide it, okay, what we're left with is an x squared. All right, as my highest power there. So now we're left with a second degree. So that means I'm going to have here 1x squared minus 4x plus 1 equals 0. So now I have a quadratic, and we can solve any quadratic that we want because we have the quadratic formula.
So after we divide it by 1, it becomes that, right?
Well, yes. So this is what this is called, the book calls it reduced form. And let me explain a little bit about what we have here. So basically we have x plus 1 times x squared minus 4x plus 1. And if we took that and multiplied it, actually FOILed it, we'd get the original one, right? Okay.
Okay.
So this is what we're going to get. I mean, I can do it for you if you want, but that's what we're going to get. Okay. So we took this thing, we divided it by this, and now we have, this is kind of the next factor, the other factor. So if we FOIL, that's what we're going to do.
Where did the x plus 1 come? We divided by -1.
Yeah, so
Oh, that's the x-intercept.
right.
You explained this so much better.
Oh, thanks. Okay, so here we go. So now what we're going to do is take this and use quadratic formula on it. A equals B equals C equals. Okay, and I know it's not complex. I mean, I know it's not imaginary solution, but it's going to be something weird because I'm getting decimals. So I'm just going to kind of work through this. So B squared, so I'm just going to put 16 there, minus 4 times 1 times 1, all over 2. All right, so I took negative B, opposite of B, plus or minus square root of 16, B squared, okay, minus 4 times 1 times 1, AC, divided by 2. So 4 plus or minus square root of 12 divided by 2. Does that make sense? What we're doing there? Okay. Now here's what the book's going to do. Here's what we want to do. So we're going to go 4 plus or minus this 12. All right, square root of 12. I want to come over to the side a little bit here. That can be simplified. All right. So what does that mean? That means I can break this down into a perfect square and a number. So a perfect square would be a number that has a nice square root, like 4. 4 squared root of 4 is 2. 9, 16, 25, all those. So this could be broken down into 4 times 3. And then if I take the square root of 4, what am I going to get? 2. So this can be broken down into that. All right. And then now I can do this division and this division, and ta-da, there we are. Okay? So there are my other two solutions. So if I took 2 and added the square root of 3, I'm going to get like 3.7. Was that one of our x-intercepts for that? About 3.7? Yep. Mm-hmm. And the other one's going to be 2 minus the square root of 3, so it's like about 0.3. Is that the other one? Yep. Yep. So see, it's giving them to you. It's just that this is an exact, and the ones you're getting are not. So technically, I guess mathematically proper, all right, this is an exact solution because if I put this into that equation there, I'm going to get 0. If I put those most of the ones in there, I won't get 0. I'll get close to 0, all right, because they're not exact. They're approximate. Okay, so that's how you go about solving one of these things. All right. Somebody's probably thinking, what happens if you don't have a nice x-intercept? That would not be good. All right. You know, you're just that's gonna take something more than what we're gonna do. All right.
That polynomial raised to like the 4th power would be the synthetic division twice, and then the quadratic equation.
We're getting there. Okay, we're getting there. All right, let's try one more here. All right, so let's try this one. So we're going to go x cubed plus 6x squared plus 13x plus 8. We're going to set that equal to 0, and we're going to solve it. All right? So, what are we going to do first? Graph it. Now, let's see if we have a nice x-intercept that we can work with. Okay, so we're going to graph it. See what happens. Let me know when you find it.
This one says it's only -1.
-1?
That's it, yeah.
Okay, well, hey, that's what we got, that's what we got. Okay, so we got a -1. All right. So what are we going to do now? How do we find the other one? Synthetic division. Okay, do synthetic division on it, let me know what you get. Good. What's our other numbers?
1580.
1580. Is everybody saying that's okay? We're good with that? All right. Well, it's a good thing we got 0, because if we didn't, there'd be an issue somewhere. All right. So what is our reduced quadratic down here? What would it look like?
1x squared plus 5x plus 8.
All right. Let's quadratic formula this, see what happens. 1, 5, 8. Here we go. Now, what do I know I'm going to get for sure? Because you guys said there was only one x-intercept. So what are these answers going to have to be? Oh, we should know that. If we only have one x-intercept, what are these going to have to be? They're going to have to be imaginary. They have to be. Right? You told me there was only one x-intercept. There's got to be 3 solutions to it. Unless there's a double root somewhere, but you said there wasn't, so let's see what we got. 32. Sure enough. What do we get on the inside there? 7, right? -7. 4 times 8 is 32, 25, yep. So, -5 plus or minus I, square roots of 7, all over 2. So there's one solution, and then my other one was -1. There's my other solution. Okay, so we're breaking it down, finding that other answer there.
Why is the first number always the opposite, but none of the rest of them are? The quadratic division.
Why is this opposite?
But none of the rest of them are opposite.
Because this is the formula goes like this: -b plus or minus the square root of b squared minus 4ac all over 2a. That's why. Okay. Yep.
So the final answer was, that's the I for imaginary number?
That's what's that?
That's an I?
This? Yeah. That's not.
Oh, because of the, you can't square root.
Correct. So that makes it imaginary, right? Okay. So if you have a negative underneath here, then that I is going to pop out front.
Okay.
Anytime you have a negative inside, your I is always going to pop out. Now, and we can't reduce this because there's no perfect square that goes into 7.
Yeah.
Right? So we're done. We can't go any further than that.
What if it wasn't having a square?
What if what?
If it was a negative perfect square, how would that look? Like if it was like -9 in the square root. Just take that out.
Something like that, right? Okay. So we have -3 plus or minus. This is going to give me an I. Yes? Okay. And the square root of 9 is what?
3.
-3 plus or minus 3i divided by 2.
Okay.
Okay? That's where you carry it. If you have that. And that's a good question. I don't know if I made up some, but I'm not sure I got up to that part where I had actually a nice number there. May have, I'm not sure. Okay. Oh, yeah.
Hey, so on the test, what would you ask us? Like, what would the question be? Like, find the zero or find no?
Solve it.
Yeah.
Solve it.
Already.
Yep, I'm just going to say solve it and give it to you, and you go for it. Okay? Find exact answers. All right. Okay, before we do the next stuff, then this would be our good time for our little 10-minute break. So go ahead and do that, and we'll come back. All right, let's dive into a few more here, and then just want to make sure I got everything covered. I just was kind of glancing at Simon a little bit, so I think I got everything. We're going to be getting everything covered here. We'll kind of go and see where we're at after that. So let's do a couple. Does anybody want to see me do another one that the solutions are not imaginary, and it was kind of like the first one we did? Is anybody interested in seeing that one where they're going to be square roots but not imaginaries? Because I can.
So imagine, our we're ending up there is where we're just taking it all. The only difference is we're coming up with a negative under.
The only difference was breaking down that square root.
Yeah.
Yeah. Here we go. All right. So let's try. I have 3 more I want to look at. So here we go. So we'll just do this one. Okay, so we'll solve this one out. I don't think we did this one yet, right? If I remember right. Let me double check. Where is that? Oh, okay. Here we go. We'll do this one then. All right. So you know what to do first. Let me know when you find it. Negative. Okay, we got -1. Let's break it down. Again, I'll let you do that. Let me know what you come up with. One, 3, 10, 0. Thank you. All right. So now we've got those. All right. Hopefully we're all agreeing with this. If not, then let me know. Let's do the quadratic formula on it. And since it has 1 x-intercept, then what do we know about these solutions? Got to be imaginary. Hopefully I got it right, I'm not sure. Did we get 31 underneath? Yeah? Okay. Negative 3 plus or minus. So remember that, again, that is 2 of them, right? And the other one was negative 1. So there's 3 solutions. Make sure you list them both. Don't just say, oh, done, and, forget all about that negative 1. Okay, because that's a solution also. All right. So Jesse said something about, well, what happens if we have a 4th degree? Well, we got to have 4 solutions. What are we going to do then? Here we go. Let's try this one out. Okay, guess what? You know what to do first. Let me know what you come up with. Two and negative 1? Well, which one do you want to work with first? 2? Okay, here we go. All right, now keep that negative 1 kind of off to the side because we're going to come back to that, right? So I know this is going to be a 1. I know this is going to be a 0. I just need you to tell me what goes in there. You got numbers yet? 1 and
4, 13,
and 10. Okay. So, what does this one break down to then? The other ones were all quadratics. What is this one?
Do the third now.
The 3rd degree,
We'll
right?
have to do it again.
So, we're going to do it again. All right? So now we take what we have here, okay? And what are we going to divide this one by, though? Yeah, we need the other root, right? Remember I said, okay, you got 2 of them. You chose 2. It wouldn't have mattered which one you chose. You chose 2. I said, well, I'll keep that other one off to the side. What was it, negative 1 or 1?
negative 1.
Negative 1. Okay, so now I know what I'm going to get here. I know what I'm going to get there. So what are our numbers? 1, 3, and another 10? Oh my goodness. Okay. Well, here we are. Right? We've broken it down to a quadratic, and by now we're probably pretty darn good at using this quadratic formula. Okay? Oops. This looks like it's the same darn thing. Okay, so there's 1. there's the other one, and there's the other one. All right, so there's 4 solutions to that. 4 solutions. So when we have a 4th degree, yeah, you're absolutely correct. Your instincts were right. We're going to graph it. We get 2 x-intercepts. We're going to break it down to a cubic, and then go one more. All right? So here's my last one, negative x to the 4th plus 4x cubed minus 11x squared plus 4x plus 20 equals 0. Okay, one last solving one. Try it out. Let's see what we get here. Let me know what you come up with. -1 again? I needed to be a little more creative. -1, and is there another one?
Yeah, negative, or positive.
And positive
2.
2? Okay. Which one you want to go with? It really doesn't matter. They like 2. Okay, here we go. Now, had one of these had a double root, then you would have went the double root twice. Okay, so could have been possible you would have had a double root and then 2 imaginaries. You just do the double root twice, because it's obviously twice. It counts as 2. Hey, what's our numbers? I know that one's a 2.
-7, -10.
Okay, so then here we go. Same thing. Okay. This time we're going to divide it by -1, and I know what those are. Then I have it broken down. I'm ready to use the quadratic formula. And I'm getting the same thing. Where am I messing up here?
Because A is -1, it would be -2 and 1. Right?
Oh, yeah. And 2 and -1. So there's my 4 solutions. Okay. So yeah, your idea was correct. That's what we're going to do. So we're going to, the solving stuff isn't too bad. Find your x-intercept, synthetic division, quadratic formula, spits out the answers. All right, there's just different situations you can have, but that's pretty much it. All right. Questions on solving them? Okay. Here's a couple things. Actually, Tanner asked a good question about, what about test? What do you think you're going to ask us? So solving, obviously. Okay. We're going to solve them, third degree and fourth degrees. All right. We're going to see something like this. Write and I said this on Monday, linear factorization. Of. Okay, so let's give this one a shot. So we're going to have x cubed minus 6x squared plus 6x plus 8. Okay, so here's what I want to do. We're going to graph it. All right, see if you can find an x-intercept. There's a nice one at 4. Okay, sweet. So that's the one I'm going to do my synthetic division on. Okay, so I do synthetic division, break it down. All right, now I have this. Okay, so it's a linear factorization. All right, we could just say, well, isn't this good enough? All right, but the problem is that this is a quadratic, so we want to try to break it down even more. So then we're going to do the quadratic formula again. This time I'm not going to get an imaginary, obviously, because I had those two x-intercepts. Let's see, 8, 12. So I'm going to reduce that 12 down, like I did before. Now, the linear factorization is going to look like this. X minus 4, parentheses, x minus, parentheses, 1 plus the square root of 3. I'm going to move this guy over here. Parentheses, another parentheses, x minus 1 minus the square root of 3. All right, so if you FOIL that, we'd end up with the same thing we started with. All right. Yeah, wow, I was right. Probably don't want to FOIL that. It's actually not too bad if you do these two first. Yeah, because things cancel out, right? So it's really not too bad.
Well, I wouldn't say they cancel each other out, but they get rid of the radicals.
Yeah, no, the radicals cancel out, right? Yeah, yeah, you're right. Okay, so it's actually pretty nice. I mean, it's not bad, all right? But that's not what the question asked. The question said, write the linear factorization, okay? Some of the problems here, say information is given about a polynomial whose coefficients are real numbers. Find the remaining zeros. And here's what it says. So let me write this out. Find remaining zeros. And here's what they say. They say, okay, the degree is 3. 1 x-intercept is 2. one solution is 4i. Find the remaining solutions or zeros. So I have one x-intercept is 2, one solution is 4i. Well, what's the other one? One's 2, one's 4i. What's the other one got to be? Negative 4i. It's got to be. Okay, remember, if you got one imaginary, you got to have two. They come in pairs. All right, plus or minus. So if one's 4i, the other one's got to be negative 4i. There's not even anything we really have to do there. It's just, that's what we're going to, if we got that for an answer, we do. Okay. Here is another one. This one's a little different. Write the polynomial with solutions so here's what they're going to say. 3 with a multiplicity of 2 and 1 plus I. All right? And the degree, oh, you don't need the degree. Oh, the degree is 4. Okay, we're going to torture ourselves a little bit on this one, so let's do it. So we got 3. So here's its solutions. 3, it has a multiple of 2, and 1 plus I. So it's a degree of 4, so how many solutions should we have?
4.
How many do we got?
Well, we know the 3.
There's 3, right? So what's the other one have to be? 1 minus I. So right now, we know that the other one's 1 minus I. Okay? This is asking us to write a polynomial. Okay? So it doesn't say the linear factorization of it. It actually says a polynomial. So here's how we're going to do this. We're going to go x minus 3. That covers that one, right? But it's a multiplicity of 2. So what does that mean? All right. So let's figure out what that is. Just that. Well, here we'll go do this one. Okay, x minus 1 plus I. That's one factorization. What is the other one?
X minus 1 minus I.
That's right. Okay, so now there it is. But that's the linear factorization of it. They actually do want us to FOIL this thing out. Okay? Oh my gosh. Well, let's give it a shot. All right, we said we didn't think it was going to be too bad in the last problem. Let's try it. Recommendation would be to do this part first, this part. All right? Don't try to do x minus 3 times x plus 1 plus I. It's going to be a disaster for you. All right, let's do the first part. We're going to FOIL that out. X squared minus 6x plus 9. Okay, that one's done. Good job. All right, now we have to do this one. So let's step through this, okay? I want to step you through it pretty dang slow here to make this little meter stick out. So we're going to go x times x. Well, that makes sense. Then we're going to take x times this thing. All right? Then we're going to take this thing times x, and then we'll do these two at the end. All right? But it really isn't too bad because this is kind of what happens. So we're going to step through this kind of slow. So x times x, that's going to give me x squared. Got that. Now I'm going to go into this one. Minus, parentheses, 1 minus I, x. Okay? 1 minus I, x. So that's done. Now I'm going to do this one. Minus 1 plus I, x. Okay, 1 plus I x. I'm not distributing the x's. I'm going to leave them. Okay, plus. Now I'm going to take and multiply these two things, okay? The 1 plus I and the 1 minus I. Nice thing about them is that they're conjugates. So, really, all we have to worry about is multiplying the 1 and the 1 and the I and the I. Because what happens when you take a 1 times a negative I and a plus I times 1, what's going to happen to those i's? They're going to go away. Alright? And that's what's good about that. Okay, so we really only have to worry about the 1 and the 1 and the I and the I. Okay, so 1 and a 1, so that's a 1. What's a negative I times a negative or a positive I going to give us? It's going to give us I squared, which is negative 1, right? But it's a negative of a negative 1, so we get a positive 1 out of that. Okay, so it's kind of weird. So we take I times I, right? That's I squared. Okay, I squared is negative 1. But I got to take the negative of that, so that's a positive 1. All right, so you see it's almost, well, kind of. We'll keep going here. So here we go, x squared. Now, again, we're going to slide this through, so this becomes a negative 1 and a plus I. Does everybody see that? Negative 1 and plus I, distributing that minus. Okay? This becomes a negative 1 and a minus I. So what happens to the i's? They go away. All right? So we're left with a negative 1 and another negative 1, which gives me a negative 2x and then plus 2. So now I have these two quadratics, and I just FOIL those. Okay. So what looked like it was going to be a real mess, it's just kind of, hopefully you're thinking, man, I hope we don't have a lot of these because this takes a little bit of time. And now it would just be a matter of just foiling that thing, okay? So x to the 4th, 2x cubed, 2x squared, 6x cubed, 12x squared, minus 12x, 9x squared, minus 18x, plus 18. X to the 4th. I got a negative 2x there and a negative 6x there. I've got a plus 2x squared there, 12x squared there, and a 9x squared there. So let's see, 2, 14, 23x squared. And finally I have those two x's and close it out with an 18. Oh my goodness, there it is. All right. So, I mean, I gave you a pretty tough one. So they'll probably give you some cubics, which would be much easier. All right. But you're going to see some like that. You know, I don't foresee asking a question like that on your test because that takes a lot of time. And I can accomplish whether you know the thing by giving you a cubic. All right. And I wouldn't give you more. I mean, probably just be a single one here to do this. Okay. And that is it. The rest of the stuff we've already done. Okay? So on your assignment, those are the things they're going to ask you. All right? Questions on any of that stuff right there if you want to look at? I know you want to do another one of those, right? No, it's not. I don't want to do one of those. Okay. All right, so Monday, we're gonna do rationals, and again, you don't have to worry about that quiz I wrote in there, because there's just no way we're gonna get through it. It's gonna be a little bit of work to get through those two sections on rationals, because they're kind of tough. And then, that'd be it. So, I will, probably work on your final review tomorrow, when I'm giving a test tomorrow, so I'll be able to do that, and have it ready for you on that Monday. So I'll have it with me next Monday, and I'll bring it in for you. You can do what you want with that, and then the week from today would be the day that we, work on your final review if you want. You can work on your little project activity if you want. You can finish anything that needs to be finished, because everything's due that day except for the project and the final. Okay, so that's the plan for the next 3 days. Is all we got, 3 nights. Okay.
And then a quick question for finding bounds that was on Monday.
Finding what?
Bounds.
Yeah, the bounds.
Is that just find where it stops being x-intercepts? Like the next whole number that's on x-intercepts?
I was looking at the bound thing. So they have an example, number 8 on 221, where it says use the bounds on zeros theorem on the polynomial 2x cubed plus 11x squared minus 7x minus 6. Okay, to find the integer upper and lower bounds to the zeros of f. So it says here are some potential rational zeros, but one of the things I told them was, well, these folks Monday, was that the thing is you just want to graph it, okay? Because that's, you don't need to do synthetic division to try all those. There's 1, 2, 3, 4, 5. There's like 10 of them, I think, 12 of them. And I just said to graph it and find the things that makes the zero. So that's what they did to use synthetic division on it, right? And they found 1 to have a remainder of 0, and 6 to have negative 6 to find it has a remainder of 0, right? And then they're looking at, they're saying that the lower bound, because it's a negative 104, you see that you can kind of graph it and see that that's going to be, this thing looks like, what does it do? Crosses at negative 6, so it's doing this, and 1 to 0. There's got to be another one someplace. Let's see. Maybe it's a double. Anyway, it's going to look something like that, I think. So I think that the number after this is going to be bounded because there's nothing that's going down, right? It's sort of like in behavior and going up like that. All right. That's what I would do with those bounds. Okay. I would look at the tails. So it says for r equals 1, the last row, only numbers that are positive or 0, so we know there are no zeros greater than 1. So in other words, this is our last 0, okay? But can't you just graph it and figure that out?
Yeah, I didn't know that you could just graph it. So.
Yeah. No, that's what I'm saying. I mean, they're going through this huge process when you could just graph it and see, well, there is no more zeros in this one, and there's no more zeros after this one, so there's my bounds.
Yeah. I was trying to work through 3.2 this last week, and I was just like, I don't know how they want me to do this.
Yeah, they, like I was telling them, is that the thing is that, this was pretty useful before all this graphing technology came out, right? Right, Renee's Descartes' rule of signs and all that stuff.
Yeah.
That was the only way you could figure things out. Can you imagine what it would be like to graph some, to find solutions for these without being able to graph? I mean, you'd be synthetic division all day. What's that?
Is what they mean by the real number system? But in the book, they say solve each equation in the real numbers.
Right.
So that's just using real numbers as roots, so like.
But, so that means that the solutions can't be imaginary.
Okay.
So you're only looking at the reals, not the imaginaries, but, yeah. So, this is a, yeah. Anything else? Last one, this is it.
I'm gonna get out. I'll do it on one. How are you doing?
How many more? There we go. Are you all right? Yeah. Oops.